All right, let's get right into one of the biggest, most fundamental paradoxes of life itself. It's a story that's happening inside your own cells right this second. It's about a fascinating trade-off between power for right now and survival for the long haul. And it has huge implications for everything from how we age to how we get sick.
And it all starts with this simple, kind of baffling question. We think of our bodies as these incredibly efficient machines, right? So why on earth would this machine intentionally, on purpose, just throw away a huge chunk of its fuel? It sounds like a terrible design flaw, but as it turns out, it's actually one of our most important features.
And the scale of this is just staggering. We're talking about some of our most energy-hungry tissues. Think about your muscles. We're up to half of all the energy we get from food isn't used for anything productive. Not for moving, not for thinking, it's just lost. It's leaked away as heat. So let's figure out why. To really get this, we've got to pop the hood and look at the engine itself. We're going way down to the cellular level, to those tiny little power plants that run our entire body. The keyword here, and it's the most important one, is deliberately. This is not an accident, it's not a bug, it's a feature. Our mitoconderia, which are the experts at turning food into fuel, have this built-in proton leak. You can picture it like a tiny, intentional hole in a dam. And the fact that we see this leak in all kinds of creatures, from mammals to reptiles, well, that's a huge clue. It tells us it must serve some kind of deeply ancient, absolutely vital purpose. So what is that purpose? Why would evolution bother maintaining such an expensive, energy-wasting system for millions of years? Well, the leading theory is pretty amazing. We're treating energy today for a longer life tomorrow. To understand how that works, we have to meet the villain of our story, reactive oxygen species, or ROS for short. Think of them like the exhaust fumes coming out of our cellular engines. They're just an unavoidable byproduct of making energy. But these little molecules are unstable, and they bounce around our cells, causing all sorts of damage to our DNA and other critical parts. And over a lifetime, that damage adds up. It's a major reason why we age. So here's how the hypothesis goes. First, that proton leak acts like a pressure release valve. By letting some energy just escape, it stops the engine from running too hot. And what does that do? Well, that's step 2. This cooler process generates way fewer of those damaging ROS molecules. The result? Step 3, less damage builds up over time, which, in theory, could slow down the whole aging process. It's this really elegant trade-off. Burn a little more fuel day to day in exchange for less wear and tear on the machinery over the long haul. And this isn't just some minor adjustment. As researcher MD Brandt puts it, evolution has decided this leak is so critical for survival that organisms are willing to pay a massive energy bill just to keep it going. So, you see, our bodies are built for the long game. But what happens when this ancient system runs smack into our modern world? And this is where our story takes a huge plot twist. We're about to see how this very same system, the one designed to protect us, might actually be at the heart of the type 2 diabetes epidemic. Now, you've probably heard the usual story about type 2 diabetes, right? It's all about high blood sugar, cells becoming resistant to insulin. And yeah, that's true, but that's the end of the story, not the beginning. The real problem starts years, sometimes even decades earlier, and the first domino to fall is in a place most of us completely overlook. And that brings us to the hero of this new story, the body's first, and you could argue, most important line of defense against blood sugar chaos, the liver. See, the liver has this crucial 2-part job. It's a glucose buffer. When you eat a meal and sugar floods your bloodstream, the liver's job is to soak up all that excess and store it, preventing a dangerous spike. Then, when you're fasting, say overnight, it slowly releases that stored sugar back into your blood to keep your energy stable. It's constantly working behind the scenes to keep you in that perfect, safe zone. You can think of it like a dam managing the flow of blood sugar, or maybe a rechargeable battery for your body. But the most powerful analogy, and honestly it's a little scary, is the last one. The liver is like a car's gas tank that has no fuel gauge. Its capacity can be failing for years, silently, without any symptoms at all. You just don't know there's a problem until the tank is totally empty and the car just sputters to a stop. So how does this incredible, finely tuned system actually break? How does our #1 defense against high blood sugar fail? Well, the culprit is the system being pushed way past its limits by one single signal, over and over and over again. This new timeline shows exactly how it falls apart. Step 1, it all starts with a constant energy surplus. Step 2, in response, the pancreas pumps out tons and tons of insulin to try and deal with it. But the liver, which is right next door, gets blasted by that insulin signal. Over time, that leads to step 3. The liver gets desensitized. It just stops listening. And that leads directly to step 4, buffer failure. The dam breaks. And only then, after all of that has gone wrong, do you get to step 5, where sugar spills out into the bloodstream, causing the high blood sugar we finally diagnose as diabetes. So let's be super clear about this. The high blood sugar and the insulin resistance in your muscles, they aren't the cause of the problem. They are the symptoms of a much earlier failure. The very first domino to fall is the liver. Okay, so let's connect the dots. We have this ancient system designed to slow aging by wasting energy, and we have this very modern disease caused by energy overload. How in the world are they connected? This is where it all comes together. On one side, you have that protective leak, right? A deliberate, ancient inefficiency designed for a long, healthy life. But on the other side, you've got our modern world. And what happens is prolonged exposure to high levels of insulin, that signal of constant energy surplus, it actually suppresses the energy production in the liver. It's basically screaming at those cellular power plants to shut down. So the system that was designed for this careful, long-term energy management is just getting steamrolled by a signal of constant, unending surplus. And that's really the final verdict here. The very same energy machinery that evolved over millennia to protect us and extend our lives is being short-circuited by an environment it was never, ever designed for. And the result is the failure of our most critical metabolic defense system. So what this new model really demands is a fundamental shift in where we're looking. Instead of just focusing on muscle cells and sugar intake way at the end of the process, it suggests we should be looking much, much earlier at the health and the buffering capacity of the liver and at the overall energy balance of the entire body. Which leaves all of us with a pretty important question to chew on. If the liver's silent decline is the real beginning of this story, then maybe metrics like blood sugar are telling us about a problem way too late. It really forces us to ask, what does it actually mean to be metabolically healthy? And have we been measuring the right things all along?